Alright, so this video is going to show us how to factor. So for example, if I have x squared plus x minus 6, I'm going to show you how to know that when we factor it we get x minus 2 times the quantity x plus 3. Well, I'm a firm believer that we build knowledge off of previous material, so what I'd like to start with is I want to start with this side and then show you how that connects to this trinomial. That way when we're given the trinomial, we can look at some key things to help us factor. Okay, so if I have all of these binomials here, we're going to go ahead and multiply them. And the acronym that we can use to help us multiply them is FOIL. So that means we're going to take the first terms, which is x squared, so x times x, which is x squared. The outside, which is which is x times 2, which is 2x. The inside, which is 5 times x, which gives me 5x. And then the last is 5 times 2, which gives me 10. And then the outside and the insides will always simplify together. So this gives me x squared plus 7x plus 10. Okay, here we're going to do that again. So first term, x times x gives me x squared. Outside is x times 6, which gives me 6x. The inside is 4 times x, which gives me 4x. And the last term gives me 4 times 6, which is 24. And again, we can simplify that to x squared plus 10x plus 24. Okay, and so for all the rest of these, I'm just going to go ahead and write in the answers. Again, I'm just foiling and then simplifying. So I'm just going to write the simplified answer. For part 3, we get x squared minus 7x plus 10. Here we get x squared minus 10x plus 24. Next we get x squared plus 3x minus 10. Number 6 is x squared minus 2x minus 24. Then we have x squared minus 3x minus 10. And then x squared plus 2x minus 24. Okay, so the goal of doing this was again to connect the trinomials with the binomials. So when we work backwards, meaning we're given the trinomial and we're trying to factor it, we've got some steps that'll help us be more, be a little quicker in solving or in factoring our trinomial. Okay, so down here I've got everything written out. So some key things I want you to look at is notice that when in the parentheses, when we have the signs that are both positive, our third term is going to be positive, which makes sense because the last term was positive 5 times positive 2. That'll always result in a positive number. Here, positive 4 times positive 6 is positive 24. So that's the first bullet point. So when the signs in the parentheses are both positive, your third term is positive. Also note that when in our parentheses the signs are both negative, that still results in a positive third term, because a negative times a negative will always be positive. Same thing for number 4. Negative times a negative results in a positive. Okay, so when the signs in the parentheses are both negative, your third term is positive. Okay, this helps us because when we're factoring, if your third term is positive, then your signs must be the same. In order to determine which of the two it is, notice the middle term here. When we had two positives here, the middle term was positive. So here positive and positive gave us a middle term that was positive. But when both of our signs were negative, the middle term was negative. So to tell if they are both positive or both negative, you look at the sign in the middle term. Okay, next let's take a look at these last 4 problems here. Notice that the signs in my binomial, it's a positive and a negative, and it always results in a negative third term. So positive times negative gives me a negative. Same thing for the last 2. Whenever we take a positive number times a negative number, it always gives us a negative. So note when the signs in the parentheses are different, your third term is negative. So this helps us because when we're factoring, if your third term is negative, your signs must be different. Okay, so that takes care of the signs of what of when we're factoring. Okay, and then I find most students already understand that when we're factoring, we want to take two numbers that multiply to the last term that add up or are a difference of the middle term. Okay, so that's what this information is saying here. So if the signs are the same, we need to find two numbers that multiply to the third term and add to the second term. So for example, if we have a third term that's 15 and the middle term is 8, so meaning we have x squared plus 8x plus 15, we want to be able to factor this right here. Okay, so we're going to put our parentheses down. The x's go in front because x times x gives us x squared. So now we're going to find two things that multiply to 15 that add to 8. Okay, so if you need to, you can create your little list. So 1 times 15, 3 times 5. Well, it turns out that the 3 times 5 multiply to 15 and add to 8. Okay, so those are going to be our two numbers. Our signs are here. We've got a positive sign, so that tells me that both of the signs in my binomial are going to be the same. This sign right here tells me that they're both going to be positive. So we get a positive and a positive, and then our numbers are 3 and 5. Okay, so this was taking a trinomial and factoring it. Okay, let's take a look at a different example. So here, if the signs are different, we need to find two numbers that multiply to the third term, so that stays the same. But now we're finding the difference to the second term. So here's an example. So if our third term is 15 and the number on the second term is 2, that means we have x squared plus 2x. Oh, I'm sorry, we need to change that to a negative. So if the third term is negative 15 and our second term is 2. So we've got this polynomial right here, and so when we factor it, we're going to put our parentheses. We know that x goes in the front. This negative sign tells me that my signs are going to be different. So one is positive, one is negative. Okay, and so again we want to find two things that multiply to 15 but now are a difference of 2. So again, our list is 1 times 15 is 15, but that does not give me a difference of 2. We could do 3 times 5. Those multiply to 15, and the difference between these two numbers is 2. So that means that 5 and 3 are going to be the numbers. To determine which one goes with which sign, notice that this is a positive 2. Therefore, the positive must have the larger of these two numbers. Okay, so there's the 5 is the larger of the two, so that goes with the positive sign, leaving 3 back here. Okay, so that's taking a trinomial and factoring it. We can always check it, so x times x gives us x squared, outside gives us the negative 3x, inside gives us the positive 5x. Notice that adding those gives us the positive 2x. Okay, and then the last 5 times negative 3 gives us negative 15. Okay, and then there's one more example. So I'll also note if the second term had been negative 2, the larger number 5 would be with the negative sign. So what I mean by that is x squared minus 2x minus 15. If this is my polynomial, then I've got my parentheses to start with. My x's go in front. This sign is negative, meaning we're going to have one positive and one negative, so they're going to be different. Okay, and again, 3 times 5 multiplies to 15, but is a difference of 2. But since the 2 is now negative, that means the larger number must be negative. Okay, and so then the 3 goes with the other one. Okay, so we can check it out again. So x times x is x squared. The outside gives me a negative 5x. The inside gives me a positive 3x. Adding those together gives me the negative 2x, which is why the larger number must have the negative. Okay, and then the last term, 3 times negative 5, gives me that negative 15. Okay, so this is the general idea of how to factor polynomials. Let's go ahead and do some examples. Okay, so it says now let's work backwards. We're going to factor each trinomial. Make sure you pay attention to your signs. As you're working through them, you should ask yourself some questions. So look at the third term. What does that tell you? And then look at the middle term if you need to, and then determine what that tells you. Okay, and then always think what two numbers multiply to the third term, and if they're the same, they add to the middle term. If your signs are different, then we're going to take the difference to the middle term. Okay, so here we've got the first example. So x squared plus 10x plus 16. I'm going to go ahead and put my parentheses. Okay, well, we can go ahead and put our x's here in front, and then we want to look at our signs. So here this is positive, so that tells me that both signs are going to be the same. The fact that the middle term is positive tells us that both of these are going to be positive. Okay, now since the signs are the same, we're going to add to the middle term. Okay, so what I'm going to do is just make a list of numbers that multiply to 16. So 1 times 16, 2 times 8, and then 4 times 4. And I want to find which of these sets add to 10. Well, it turns out that it's 8 and 2. So I'm going to plug those numbers in, and it's factored. Let's move on to number 10. So again, we're trying to factor this. So I'm going to put my parentheses and my x's in front. This positive sign tells me that my signs are the same. This positive sign tells me that my signs, again, are going to be positive. So we want to find two numbers that multiply to 12 that add to 7. So I'm going to make my little list. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, and it turns out that 3 times 4 multiply to 12 and add to 7. Okay, so that means that my numbers over here are going to be 3 and 4. Okay, next we're going to factor x squared minus 4x minus 12. So we've got our parentheses, put our x's in front. Okay, this negative sign tells me that my signs in my binomials are going to be different, meaning one is positive, one is negative. Okay, so we're still going to do a similar idea that we're going to find all the numbers that multiply to 12, but now are a difference to the middle term because our signs are different. We have a positive and a negative. Okay, so we still have the same list. 1 times 12, 2 times 6, 3 times 4. And the ones that are difference of 4 is the 6 and the 2. Okay, so that tells me these are the two numbers I'm going to use because they multiply to 12 and are a difference of 4. Since this sign is negative, that means that the 6, the larger number, must go with the negative. So the 6 goes with the negative, leaving the 2 to be with the positive. Okay, number 12, we have x squared minus 5x plus 6. We're going to start our parentheses, put the x's. This sign tells me that my signs must be the same. This is the one that tells me which one it is. So since it's negative, that tells me both of those signs must be negative. Okay, and again, these signs are the same, so we're going to find two numbers that multiply to 6. So these are the possibilities, 1 times 6, 2 times 3. And we want to find, since the signs are the same, two numbers that add to the middle term. We have a 5, so that means that we're going to use 2 and 3, since they add to 5. Okay, since they're the same, doesn't matter which one goes where, we just put in the 2 and the 3. Okay, number 13. Very similar to number 12, the only difference is this 6 has a negative instead of the positive. So again, we're going to start with our parentheses. We have x in the front. So we look at our signs. This sign right here in front of the third term is negative, which means that the signs must be different, because we must have a positive times a negative to get a negative third term. Okay, so we're going to find two numbers that multiply to 6. And since these signs are different, we want to find a difference to the middle term. So it turns out in this example, we're going to use 1 and 6 because the difference of those give us the 5. Okay, since it's a negative 5, we're going to take the larger of the two digits over here. 6 is the larger number, so that means 6 goes with the negative, leaving 1 to go with the positive. Okay, so these two binomials multiplied together give us this trinomial over here. Alright, what I'm going to let you guys do is take a moment and practice these last four. While you're practicing it, go ahead and pause the video, and then when you start it up, I will have the answers for you. Alright, so here are the solutions to the last four problems. Notice that here when our variable was y, I have y in the front, and notice here when the variable was m, I have m in the front. Okay, so that is it for just factoring polynomials. Notice that all of these have a coefficient of 1, meaning that the number in front is 1. So it makes it pretty easy to factor these types of trinomials. Okay, the next video is going to show us how to factor when the coefficient is not equal to 1.